And welcome back, students. I wanted to take another take at this problem. You've seen the problem already. And in a previous example of this same problem, I used the grid method. What I want to do here is just show you the long method, which essentially is the dimensional analysis of the problem, at least that version. And so let's go ahead and do this here, and let's identify some of the key pieces that we need. So remember, always begin by identifying the information provided that's relevant. And so I'll do that here. Numbers are extremely important. So notice we've got 34.6 grams of carbon monoxide. And so here the unit of grams is important for us. And then the other number is 88.1 grams. Again, the units are important of the H2. Now it's important for us here to identify that the 34.6 grams is pertaining to the first reactant and the 88.1 grams is for the second. So the main thing that is available here, or should be known to us at this point, is that we are provided the starting amounts of both of the reactants. And whenever this occurs, you have to think automatically, I need to figure out which one of these reactants is going to run out first. Whichever one runs out first is the identity of the limiting reactant. And so what I'll do here is to essentially bring your attention to the fact that we've got grams once more. And the process here, if we're setting up a game plan, we're going to have to convert this information first into moles of carbon monoxide, and we're going to have to convert this number here into moles of hydrogen gas. Once we know the moles of each one, at the start, we also need to figure out how much of the other compound do we have or do we need in order to fully react. Once we figure this out, we're essentially going to be in a position where we're going to take the moles that we have versus the moles that we need, and then you can take the difference and you should be able to identify the limiting reactants there. And so I'll just modify this moles of CO, I'm going to put here at the start, and the same thing here for the moles of H2 at the start. Okay, and that's essentially going to be what you have, and I'll put that in, I guess, parentheses here for both of these, just to make the distinction. And so what I'm going to do is I'm going to kind of do the work here. I might move some things around the screen, but I'll try to do the work here on the right-hand side to kind of just keep going and flowing. So we'll start off with the very first one. So I'm going to go ahead and pick the first compound, carbon monoxide. I'm going to take these grams and I'm convert it to moles of carbon monoxide, as the writing here indicates. And so I'm going to use the color here. Let's use blue. And so I'm going to take here 34.6 grams of CO. And it's important that you write the identity of the compounds, only because it builds good practice. You want to make sure you have this skill down in preparation for the AP exam. Okay? And so when you go here, we are going to need the molar mass. And so keep in mind that in order for us to get the molar mass, we do need to figure out the total masses here. So what you're going to do is you're going to take the mass of an oxygen, mass of a carbon, add that together, and that's how you get the molar mass. And so in this particular case, the molar mass of carbon monoxide is 28.01 grams for every 1 mole of carbon monoxide. And so all I'm going to do here is write it in this fashion here, because now I can come in here and cancel. Notice my units of grams of carbon monoxide, I need to put a C here, gets canceled as well. So that, and what's left is moles of carbon monoxide. And so let's go ahead and do that math there. And so if you do the math here accordingly, what you're going to wind up getting here is a value of 1.2352, and this is going to be moles of CO at the start. Okay. We're going to do the same thing here for the other one. So let me just move this a little bit over this way, and let's see if I can, yeah, let's do that there. Okay, and then down here we're going to do the same thing for the other one. We're going to take the information here for the 88.1 grams of H2, set this up using dimensional analysis, and we know for every 1 mole of H2, it's going to have a mass. So what you're going to have to do here is add up the mass of 2 hydrogens, that's 1.008, add them together, and what you wind up getting here overall is 2.016 grams. clean this up here. Notice the grams of H2 cancel. Up here I have to put the H2, so let's go ahead and put that there. And that will cancel as well, leaving you the units of moles of H2 behind. You do the math there, 88.1 times 1 divided by 2 gives you a moles of 43.70 moles of H2 at the start. Okay? And so let's kind of move this out of the way, move it this way, and move it a little bit smaller. Now, when you're at this point, the next thing you got to figure out is you've accomplished the task of going from grams to moles. We've already got this information, okay? And so what you want to do at this point is ask the question, if I start with either one of the reactants, how much of the other compound am I going to need? So let's kind of just start here with this one here. We'll start with the carbon monoxide. Since we already know the number of moles, let's just figure out if I start with 1.2352 moles of carbon monoxide, how much of the hydrogen gas am I going to need? And so what you can do here is you can just continue on the math problem. Here, just extend it. And what you're going to need to do now is to look at the relationship between the two compounds. So the relationships that we're going to look at here involve a mole ratio. So we're going to look at the mole ratio between carbon monoxide and hydrogen gas. That means you look at the coefficients. So for every 1 mole of carbon monoxide, I'm going to need 2 moles of hydrogen gas. And so we're going to set that up over here as a ratio. And so what we'll do here is put that into practice. Notice here, carbon monoxide shows up in the numerator. So what we're going to do here is we are going to put carbon monoxide down here, moles of carbon monoxide, relative to the other compound, which is going to be moles of hydrogen gas. We're going to look at the value here. Notice the coefficient of 1 for CO, so we're going to go ahead and place this down here. We're going to put a 1 there, and so that'll be for every 1 mole of carbon monoxide. Notice here we have 2 moles of H2, so that means we're going to have to put a 2 up top in the numerator. Okay. What we'll do now is we're going to go ahead and cancel. Moles of carbon monoxide cancel. Notice here what we're going to have is moles of hydrogen gas remaining. And so if you do this, you're going to take the 1.2352, multiply that by 2, and you should get the following answer. It's going to be approximately 2.4. Okay. And so that'll, I ran out of space here. So what I'm going to do is I'm going to put the number up here. Okay. So that'll be 2.4704 moles of H2. And here's the important part, needed. Okay, so you need 2.4704 moles of hydrogen gas. If you take this number and compare it to how much you actually have, notice that we've got 43 moles of hydrogen gas at the start. We know this from the previous calculation we did. Compare that to the 2.47 moles that you actually need, and you actually have a lot here. And so the way you figure that out is you're going to go ahead and take the moles that you have, which is essentially, let me kind of separate this out here. I'll put this in the corner. We're going to take the have minus the need. And so here we're going to take the 43.70 minus the 2.47. You can do the math yourself, but notice here that this is going to be a positive number. Okay? And a positive number here equals excess. Now you can actually calculate the difference there in terms of excess, and I have already done that, so I'm going to go ahead and put this here. The excess is 41.2296 moles of H2 excess, or 4.21 moles H2, yep, excess here. And so if the problem asks for that, you've already got that calculated. Now if the problem's only asking you to figure out the limiting reactant, obviously since H2 is in excess, that means that the other compound is going to be the limiting reactant. So in this particular case, the limiting reactant here is going to be the carbon monoxide, which I'm just going to abbreviate here at the very top with LR. All right. Now that we know this, we have to use this information to help us out in terms of solving the problem. So I'm going to go ahead and erase some stuff here from the screen that I don't need anymore. I'm going to go ahead and take this out of the way. And I'm going to erase, I guess I'll move some of this stuff out of the way as well. Here. And what I'm going to do here is just move some stuff. Oh, it didn't quite work. So let me go ahead and do this. let's get rid of the excess because we don't know. We don't need the excess anymore. We've already identified that this one here is the limiting reactant. And so we're going to use this information to get to the product. And notice here what we've got is we've got carbon monoxide, and the compound that we need to relate it to is the compound that's identified here, which is this other one here. You are going to need a mole ratio, but right off the bat it should be pretty obvious. The ratio is 1 to 1. But stoichiometry wise, let's kind of set it up. Always begin with what you've got. The limiting reactant, 1.2352 moles of carbon monoxide. We're going to use the ratios between these two compounds, the limiting and the product that we're looking for. So for every 1 mole of carbon monoxide, that's going to be producing 1 mole of the CH3OH. Okay. Notice here, moles of carbon monoxide cancel, and so what you're going to end up with here is the final answer of 1.2352 moles of CH3OH produced. Okay. And so that would be your answer there, and then this would be the other answer here at the very top. Carbon monoxide's limiting. I know that this video was a little bit longer, but we are using a little bit more. I explained a little bit more dimensional analysis. But keep watching, keep learning, and if you haven't already done so, go ahead and subscribe, and we'll see you in the next video.